This is also in Minitab Workspace. Love, love, love the new process mapping tool. So if you ever used Minitab Workspace for desktop, the process mapping was great. Now with Minitab Workspace in the Minitab Solutions Center, the process mapping is awesome. It's so easy to use. As you click, you get little plus buttons that you can just add a new shape just like that. It automatically connects them. You click on a shape, you automatically get all kinds of options to, do things like color it. Just very interactive, point and click and go, very fast, easy way to create process maps. So in this process map, we're just looking at, the process of making this particular tumbler. So we're preparing the raw material, we have to form the metal, we'll look at the how we make the lid and the seal of the lid. We've got the threading and fit control, that's the top of the tumbler and how the lid goes on it. We've got the coating of the tumbler and the surface finish, the really important vacuum insulation between the two levels of the tumbler to make sure that there's no conductivity of heat between the inner and the outer layer. To test that, we'll do some leak testing. We do the final assembly, and then we have a final quality control and testing, and then we're going to package, distribute it, and then it's out. The reason why this process map is so important here is now we've kind of focused on designing this tumbler. Now we're seeing how this design of this tumbler kind of is going to move into manufacturing and testing. And what we'll do after this process map is another FMEA that's based on what could go wrong in all these process steps. So then we can feed that back into the design team to say, hey, maybe you didn't think about this so much. So all of this is still really part of the design process. We're just starting to think about how this manufacturing end is going to work, and we'll move all of this information into our process FMEA and think about everything that can go wrong here. In Minitab Workspace, one of the best tools that's in there, I think, is the ability to do a Monte Carlo simulation based on a model that you get from Minitab. So all I did was I saved my Minitab file, and then I was able to bring in this file, and it automatically knows the models I have from my response surface design. I'm pulling in all these models, importing them just by the click of a button. It automatically pulls these models in, and then I can run a simulation around them. And the reason why I do that is if we look at these inputs of additive, temperature, and thickness, we're going to add standard deviations around them. So we know that we're not going to be able to keep the additive at exactly 13.5. Right? We're going to add variation around each of these variables and see what that really does to our process. So here it automatically created or pulled in the models. I don't have to do that. I've added my standard deviation. I have the what the current settings are that Response Optimizer in Minitab found as the optimal. And now I can add my spec limits here. And what I'll see, so I have spec limits for each of these response variables. And I click go, and this tells me how each response is going to do in more realistic terms, because I know I can't set my temperature at exactly 500 and keep it at that. So assuming the variation in these factors or X variables, here's what I see for Y. And so with my current optimal settings that Optimizer gave me, I see that material strength, I'm still going to have about 0.58% out of spec, which corresponds to a CPK of 7.7344. Thermal conductivity, I'm going to see about 0.02% out of spec, given the variation that's going to actually happen in my X's. And then leak decay, this one's really problematic because my out of spec is 3.53%. So that means that vacuum insulation in my tumbler with the settings that I think are optimal are still going to result in about 3.5% out of spec in terms of the leak decay. That's kind of my worst variable. What can I do about that? Well, Monte Carlo then, given what we've put in about the variation around those X's, is going to allow us to kind of look over a range of values and further optimize those parameters. So I click optimize parameters, and it comes up with better ones. It says, you know what? The original setting for the amount of additive to add was 13.5. If we make it 9.95, we're going to end up with a better result. My original temperature was at 500. If we reduce it slightly, we'll end up with a better result. And my wall thickness was at 1.25. Those were my previous settings with the standard deviation around them. If we change that to 1.4, we'll end up with a better result. Notice my standard deviation hasn't changed. I'm just moving the mean, but I'm accounting for the variation in these factors. And what I've seen is my out of spec actually got worse for strength, but much better for leak decay. I went from 3.5% out of spec to 1.63%. Can I do even better? Well, if I can actually reduce the amount of variation in any of these settings, variation's the enemy, right? If I can reduce the variation in any of these factors, I am going to have a better chance of having a capable product. So let's look at the variations. So the next step in a Monte Carlo is we're going to look at each of these response variables, but the real problematic one I'm going to focus on is leak decay, and see how the variability for additive temperature and wall thickness, the factors, impact my percent out of spec. Now, this is maybe a little hard to read, but we see that temperature and wall thickness, we kind of have a flat line. So that variation in those factors doesn't quite have as much impact as the variation in temperature. So here's a thought. How do we control variation in temperature? Maybe we can do something with the oven, either add a better thermostat, put a new thermostat in the oven, or purchase a new piece of equipment, do something to better control the temperature. We could reduce that by variation by, say, 30%. So we do something with this temperature to reduce the variation that's happening in temperature, then we're going to better be able to control our leak decay. Let's simulate the results. If we can actually reduce the variation in temperature by 30%, what happens? Well, now we're at a true optimal, right? So we've simulated that if we can do that, our percent effective of leak decay, which started at 3.53%, went all the way down to 0.3%. And our other variables are much more capable as well. So our CPKs 1.22, 1.84, that's looking great, 0% defective on conductivity. And leak decay, we still got some defects. We have some room for improvement, but much, much better if we can reduce the variation in this temperature variable from 125 down by 30% to 87.5. And as engineers, we know that's the best bang for our buck, because reducing the variation in additive and wall thickness didn't really help us much. It was reducing the variation in temperature had the biggest effect. So let's focus on this oven now and see how we can reduce that annealing temperature. And this will get us to a much more capable process. So there you have how to use a Monte Carlo simulation from Minitab Workspace to improve, and that's a big part of Design for Six Sigma, for even changing your equipment out, right? Simulating first to make sure it's worth the expense and where you want to focus. So there's a nice kind of use of Monte Carlo simulation by taking your optimizer output from Minitab statistical software and adding some variation to those X's, which is much more realistic of what your process is. All right, so now we've made it through the optimize phase. We know what settings are going to optimize where we are with our new settings, how we're going to optimize our three main outcomes of strength, conductivity, and leak decay. We're ready to move to the verify phase. So in the verify phase, we have really three main things we're doing. This is very, very similar to the control phase in a DMAIC process. We're going to look at a control plan, how we're going to control these variables, and we'll actually fill out our control plan starting with our house of quality information. And then we'll follow these variables using control charts and capability analysis. So this, again, control plan comes from Minitab Workspace, a really great way to set out all the stuff that we know is important. We've actually found the design parameters earlier. It automatically populates with these things, and how we're going to, what the specification limits are and how we're going to control them. So that's just a nice worksheet that comes in with Minitab Workspace.